So I actually had to redo this one. First off, because when I typed it in the first time, I made a typo and it just threw me off, and I didn't want to waste 5 minutes of your time. First off, you might look at this thing and think you can graph it. You can't graph it. It's got that I in there. If you tried to graph this thing, and that's the original equation, and did a zoom 6, you don't see anything. It's that I doing it to you. So what you do is you, again, take something like pi, and you store it to x, and you type in the original equation. First video I did on this question, I apparently mistyped the original equation, and it just screwed me up because I never looked back and saw what I was typing. That's what I get for assuming I'm right all the time. So you plug in pi into this thing, and it returns 59.22 plus 5.87i. Maybe you can see that, okay? Here's the key. Type in the key. If this is multiple choice, again, this works. If this is not multiple choice, this does not work. And we have numerical equivalency. Simplify this thing. It's doable. We'll let y be pi, and we'll let z be something funky like the root 2. Just weird looking things, okay? So alpha 1, take a pi symbol, second pi, store alpha 1 for y, take a root of 2, store, and if you look for the Z on your keypad, you'll see it's the number 2 key. I know it's kind of small on a phone there to see, but it's the number 2 key. You should really download an app or get a TI-84 from the library or something. And those variables are stored. I'm going to click Math. Oops, sorry. I actually could do that. I hadn't shown you something on these things. If you hit Math, you'll see cubic root. I hate showing you that because I really need you to learn your exponent rules, but it's there. It's always been there. I've always known it. Type it in. 128. What do we got first? We got alpha y. She is raised to the 10th power. Alpha z raised to the 18th. And if I just plug crap in, I get about 1830.88. Now, what does my key say the answer is? My key says 4y cubed z to the 6th cubic roots of 2y. Fair enough. So let's type that in. 4y to the 3rd z to the 6th cubic roots, again under math, there she is, of 2y. They're the same thing. All right, moving on. These are like you can't cheat these. You just got to do them. I guess this you could find. You can do this in the calculator. This can be done. This can't. The key on this one is 3x squared over 6x minus 10. Why you would need a calculator is beyond me. Why you would need a calculator, I don't know. But you could, some kids just struggle. You could just take something funky again, like a pi, store it to x, hit math, number, numerator over denominator, 3x to the 2nd over 6x minus 10. And like I said, that's it. So I don't know. It's not like it's going to be simplified or anything. All right, you can check your work with long division. So what is this, number 11? I wrote down 3x minus 4 plus 5x minus 5 over x squared minus 1. And I'm just going to do the make up a random thing and store it to x. I'm just going to keep using pi. And by the way, I just keep doing this just to remind you of how to do it. It's already in the calculator. Whoops, did it backwards. Take the pi and store it to x. And I'm going to type in the original equation. So math number, numerator over denominator, 3x to the third minus 4x to the second plus 2x minus 1. And it's sitting pretty over x squared minus 1. And I get this funky decimal. It's like 6.63. Well, let's check my answer. This is how you can check your work, or you can cheat. You can also do graphical equivalency, which I'll do as well. Whoops, go to x to the second minus 1. Perfect. Same thing. All right. It actually makes more sense on this one to try graphical. This is something that can be graphed. Oops. I don't know why I'm messing up. I probably need to stop. Plus, I gotta get stuff ready for the next class. Zoom 6 it. And this will be the original function. Rational graphs always look kind of funky. You can maybe see that's blue. Now I'm going to type in underneath it the supposed answer. And again, just graph it. And we should see a complete overwriting. Perfect. Can I help you with inverses? Okay, so to do this, we have to graph three things. We have to graph this guy in y1. In y2, we're going to put x, which is the line of symmetry. And in y3, we're going to put the answer. You can actually kind of cheat a little bit, but you have to understand what symmetry is. And I'll show you something that's not symmetrical. So here's the original, 4x minus 5, just zoom 6 it. And we're going to put an x in here for y2. There's the line of symmetry. Now, if you understand symmetry, the correct answer would look like that. It would just be perfect reflection over that line. So I'm going to put in something that is not that. X to the second, if I can do it right. X to the second, I don't know, say plus 5. They're not symmetrical. All right? That's not the answer. The correct answer on that one, according to the key, is x to the second plus 5 over 4. And I'll show you how to do this numerically too. X to the second, oops, got to open up the fraction, math number, x to the second plus 5 over 4. Boy, it's been a while since I've done domain. I think I'd pull up curly braces. X was supposed to be greater than or equal to 5/4. Second math, greater than or equal to 5 over 4. Been a long time since I've done this on TI-84. Wouldn't surprise me if it says go to error. Oh, cool, it actually worked. Oh, no, it didn't. I forgot to put y equals x in there, didn't I? That's what threw me off. You can kind of see that reflection right there. Why it drew the stuff on the left-hand side is beyond me. Couldn't tell you. But it did. Don't know why. What would be nice here is if I actually had a 4 there and it'd look better. It's probably threw it off. There's your line. There's your reflection, pure reflection. Now, how can you do with this with numbers? Boy, that's a lot more complicated. What you can do is you can find f of pi in the original problem. See what it generates. The root of 4 pi's minus 5 is about 2.75. And then you can take your inverse and see what it generates. So I'm just going to take that result and store it to x. I'm going to type in the inverse. Now, if you understand inverses, the input becomes the output and so forth. When everything's said and done, this ought to return pi 3.14. And it did. That's a numerical analysis. Worth knowing, worth understanding. If it throws you off, you're just going to have to write inverses. That's all calculator. No. Here's one easy peasy. Can be done straight up in a TI-84. Y1, Y2. If there's more than one answer, it'll show it to you. If there's not, it won't. It's not asking about extraneous. And you're going to have to look up 1100 units or so. So you go to Window, Ymax 1100, graph, and you can tell that you're going to have to start looking right. Window, Xmax, let's go out to 30. I thought 30 would do it. Second trace 5. Get that little blinky dude close, and then you press that magic enter key 3 times. Enter, enter, enter. And there she is, roughly 17.13 or so, whatever it was on the key. 17.1257. 17, nope. 17's not even on your quiz. 19's really easy. Like some of you morons. 19, 20, 21. If multiple choice, graph the answers. Like graph them. Like that's it. So I'm just going to do number 20. And the key for 20 says -2 x minus 2 cubed plus 4. -2 x minus 2 to the third power plus 4. And I'll just do a standard zoom 6. It looks dead on. It does. It really does. You got this point here at 2, 4. By God, there's one there at 2, 4. It looks like you're crossing the x-axis at just a touch over 3. You're doing the same thing there, and the direction's the same, high to low. So, you know, don't be that kid. (22) and 23, you can do the same as you've done the other ones. You can just make up numbers. Make up numbers. This is kind of interesting. And I'll show you how to do this one. We're going to take an x, we're going to store it to pi. We'll take a pi, store it to x again. Hit math. I want a fraction to start off with, numerator over denominator. Math, you see that guy right there? 8x to the 7th. Math, that dude right there, 5x. And I plug in a decimal and I get like 2.17. And again, back to my key here, which this one had to be corrected. But the key is the 40th root of x to the 27th power. So let's see what it generates. Math, number, math, root x. She's a 40th power, and she is x to the 27th. Numerical equivalency. You could also do graphical equivalency, although those would look a little funky. And you can do the same thing for here. Let's see, what's the key? The key on this bad boy is 7z, and you don't have to use the z. 5th root of 2z squared. But there's a z there, so I'm just going to use it just to show you guys you can. I'm going to take a pi, I'm going to store it to z, and I'm going to type in the original equation. You know, if I don't understand this stuff, God, I wish you would. I can just type this in. 3 math root x, oops, 3 math. I think what it's going to do is it's going to put that up as a root. Yeah, it did. You actually have to hit 3 times math root x. Oops, you didn't see that. If I hit 3 math root x, look what it does with the 3. It's in the wrong spot. You actually have to hit 3 times math root x. You have to insert that multiplication symbol. Otherwise, the calculator just tries to fix you. That is a fifth root, 486 z to the 7th. We have minus 2 z. Might have to insert that multiplicative. Oh, do. If you don't insert the multiplicative symbol, it really messes you up. 2 alpha z times math. I don't ever use these things. I actually just convert to exponents and go upon my life. So I made up a number. I got like 39.93. Check my key. My key is a 7z. And she is raised to the singular power times the fifth root. I don't know why I put that there. The fifth root, math root x of 2z squared. Oh, they work. So there you go, kids. That ought to give you enough information to pass the test without knowing any algebra. All you got to do is have watched the videos. And that's on you. I spent 30 minutes this morning making them. You can spend 30 minutes watching them.